Okay. I'm gonna get rid of this graph. I don't need this right now. Okay, so number 20 for right now, and then we'll go to a different one here in a second. Let's just get rid of that. Okay. This is number 20 on page 62, so it was on that first assignment. This had 5 feet, this had 16 feet, and this number here was what, 8 feet? Is that right? Is that what it had? Okay. I think it was 8. Let me double check. 8. Okay. So that's 8, and they had 12 feet here. Okay, ignoring the dashed line, so if you ignore this line right here, what is this picture?
Triangle.
Triangle, boom, so you're got a point. Because remember, I want you to ignore all book directions on that homework. You have to tell me number 1, what was the name of the object? It's a triangle. Number 2, you have to find perimeter of that picture. So if you need to find perimeter of this, get rid of all these. So if you need to name the perimeter of this, what numbers do I have to add for perimeter? Please.
The 16, 12, and 5.
Yeah, 16, 12, and 5. These are the numbers you're adding. The reason why you don't add the height, because that's not a part of perimeter. These are what you have. The label is going to be in feet. I know the book says change everything to inches. That's stupid. Why? There's no point. So we're going to change, just keep that feet, add them together, that's what you get. Okay? What is it, 23 or something like that? Questions on, no, 32. 33? 33? All right? 33. Questions on how we do perimeter, how you add them together and you just get your feet. Okay, now let's talk about area. This is what I'm kind of worried about. Maybe you found it was easy, maybe you didn't. I want to talk about it. How do you find area of a triangle again?
Base times height, like times a half.
Yep. Half the base times height. So you can take half times base times height, or base times height and then divide by 2. I don't know how you want to think of that. What's my base on this triangle? 5. That's your base. It's 5 feet. It's just the part that it sits on. Okay, I know a lot of people want to find this whole thing here. That's not the base of the entire triangle. The base of my triangle is this one. It's the 5 feet. How tall is it?
8 feet.
That's where you use the 8 feet. Because it's leaning, you have to use how tall it is. From bottom up straight, and that's why they gave you this line across, to show you that's exactly how tall it is if you just drew a straight line across. Okay, and then whatever that number is, then you cut it in half. So that's, when you multiply these together, you're going to get feet squared, and then you're going to cut it in half. I think it's like 20 or something like that, 20 feet squared. That's your area. Questions on number 20? Okay, I think these are pretty straightforward. Let's go to the second page now. So now I'm on page 70, 71, those. So now we're into 3-dimensional pictures. And I want to talk about number 21. 21. Still a triangle again, but I want to talk about 21. Let me draw the rough picture of what we have here. But because this is one, the reason I'm bringing this one up is this is one problem that I didn't discuss and how to do it. And I think we got to make sure we know. Okay? All right. 6, 8, 5, 10. Okay, were these in centimeters?
Yes.
They're in centimeters. Okay, perfect. And I want to make sure we got all the numbers in good spots. 6 and 8 were switched. I think we're fine. Centimeters. All right. The book says switch them to inches. Stupid. Don't do it. Ignore it. This is supposed to be 3-dimensional. It looks like a block of cheese, like 3-dimensional. So you got that thing and it goes to the back and it's supposed to carry all through, kind of like a tent or a lean-to on a building. But what's the name of the 3D object though? It's a triangular prism. Yeah, it's a triangular prism. We didn't really discuss these the other day, and I felt kind of bad, so I thought we better talk about it before you get to the formulas. You still do the exact same work. Define.
Kate and VTech, please come to the office. Kate and VTech.
Okay. Define surface area. Because that's the part you have to find when you do prisms or three-dimensional. This is one of the first things you have to do. You have to use your surface formulas for the prisms. So if you go in your book and you see the surface area for a prism, the prism formula, by the way, if you go back, the chart that I gave you is online. I put it on my website, so you can always use that chart if you need to. But it's surface area for a prism is whatever P is, that's perimeter times height. So it's perimeter times height, and then you're going to add twice whatever the area of the bases are. Twice the area of the bases. So perimeter times height. That's how you find surface area. And perimeter is whatever the bottom is. So what I mean by that is this thing, its footprint, its base is actually a right triangle. So if you can find the area of this triangle, there's going to be two of them. That's what this is. That's its base. That's how you name it. The base is actually how you name it. That's why they have two of the areas of the base. So that's the 6 times 8. Okay? But then the idea is that for the other objects, you're doing the perimeter and then the height of those things. Okay? You don't have to do this. Maybe you're looking at this formula and you're like, I have no idea how to find perimeter of that, and then take it times height. Maybe you don't, like, that doesn't work for you. You could do instead, you could just take this thing and find each of the surface areas separately, like that rectangle there, that is a rectangle, it's 10 by 5. You can find the rectangle in the back. You could find the area of this thing, the area of the triangle in the back, and then the bottom plate. You could do it that way. And you could add up all those surface areas separately, because if you're actually looking at this thing, there is a rectangle. There's a rectangle on this wall over here. There's a rectangle back there. There's a rectangle on the bottom. And then you have your 2 triangles. So you could add those up separately. But what they're talking about is the perimeter. It's the perimeter of the base. The 10, 6, and 8. You add those together, and then you take it times how tall it is. If you were to stand it up on its edge, which is 5 in height. So that's doing 6 plus 8 plus 10, which is what, 24? And taking it times the 5 centimeters, that's how tall it is. And then the areas of the bases, 6 times 8 cut in half, is half. The base times height. And we have to take that times 2 because there's 2 triangles there. So that's one way. So I don't know how you want to approach that problem. Me personally, I'm not even joking, like I would just find each area separately and add them all up. That's just how I do it. That's how I see it. It just makes more sense to me, doing the rectangle separately, adding them up. But if you want to follow this, the perimeter is the base that it sits on. It's this triangle, that's your base. Then everything goes up from there, and you have your little triangle wedge going up. That's why it's 5 in height. Okay, questions at all about surface area of that triangular prism? There's 2 different ways you could do it. You could follow directly this formula. And the base and height of that triangle is 6 and 8, by the way. So, if you want to know. Alright, or the volume of this thing. Volume. The volume is where you take the area of the base and you take it times how tall it is. So if you look at the formula in the book, they say B and H for volume. So volume equals B times H. That's the area of the base, which we talked about earlier was half the base times height, which is 6 and 8 of mine. That's the base of this thing. This is the base. And then we're going to take it times how tall it is, which is the 5 centimeters. So that's the tent going up. So that's the area of the base times how tall it is. Notice I'm not using 10 on that formula at all. Base and height of the triangle is 6 and 8. Cut that in half, then you take it times 5, and that's your volume. Because how you find volume of a prism? Doesn't matter if it's a rectangular prism, like this, like if it's a deck of cards, you find the area of one of the cards, length and width of one of the cards, and you take it times how tall they are. Like how many cards you have stacked on top of each other. And that's the volume of your deck of cards. That's the idea. And just to give you a real life situation why we'd ever have to find volume is that I had Jace Prince was in here this morning. He's doing I don't know if it's a project, I don't know if you even know. They're doing a fish tank where they're trying to hold tilapia. I don't know what it's for. But maybe it's just a college project that he's working on. But he has to find how much water's in a tank to hold tilapia fish. And then he has to figure out how to aerate the tank to keep airflow through. And his tank was really weird dimensions. It was this. This is seriously the problem he brought in this morning. It's a tank that goes downhill. So it has flow out the back. And the tank itself, when he came in this morning, was like at the very shallow end, he wants it to be 30 centimeters, about 1 foot deep. At the deep end, he wants it to be 3 feet deep. It's going to be 60 by 40 in dimensions. So 60 feet by 40 feet. It's a pretty big pond. And he wants to know how much water does it hold. That's a 3-dimensional shape. It's not quite a prism because it's, it technically is a prism because it's very square going up the other side. But the problem is you had to separate into 2 parts. So what he couldn't see is he couldn't see this. He couldn't see that all you had to do is separate it into a rectangle on the top, like a rectangular prism, like that little shoebox at the top. And then the bottom is a triangle wedge, which you guys are looking at. And you had to add them up separately. I think that gallon, that amount of water, in every cubic foot of water, so you have 1 cube by 1, 1 foot by 1 foot by 1 foot, like a box of water, that holds 7.48 gallons of water. 1 foot by 1 foot. Your tiles on the floor are about 1 foot, so imagine 1 foot coming up, and that's your perfect cube box that you have. It holds 8 gallons of water. His tank, this thing, holds 35,000 gallons of water. And now what he has to figure out is how much oxygen those fish are going to go through. He has about 4,800 fish in there. So we have to do research on how much one fish can burn through in oxygen, in a 6-month period. And he has to figure out, will he deplete all the oxygen out of the tank? Because he's going to have 4,800 of them in there. So they're going to deplete the oxygen pretty quick. What's the airflow? What's the water flow he has to have pumping out, pumping in, so it keeps the fish alive, keeps them healthy, doesn't allow algae to grow. That's a project he came in this morning and dumped on my desk. That was after you guys left for a review. He walked in here and dropped that problem on my desk. Yikes, and I can't get it wrong. Because that's a very expensive project if he kills all those fish, 4,800 fish. Okay, so that's a real life practical application of this. That you're finding volume, you're finding surface area. He's doing a couple different ways. I remember a problem in my ACT when I took it in high school. That was the problem. That was the exact drawing. It wasn't those numbers, but that was the problem. It asked for what's the volume of it. You have to do the rectangle on the top, add the triangle wedge on the bottom, and what I thought of is just it's like this deck of cards. You find the area of the top, and you take it times how tall it is. So I was very good at that. Rectangle, how tall? For the triangle, find the area of the triangle. Find the area of the triangle. And then once you have the triangle, take it times how deep it is, how tall it is. That's what you're doing here. Find the area. How tall is it? It's 5 going to the back. That's the volume. That's just how I see images in my head, so it makes it a lot easier to deal with. So you can break it up into parts. And how you find the dimensions of this triangle on the bottom, it's 60, but then this number is about 2 feet, right here, from here to here, because this part is about 1 foot deep, because it was going straight across. And that's kind of what we just estimated. Okay, questions? Perfect, okay. Let's go take some notes now, so you can put everything away. You can just have your notes out. I'll give you some time at the very end of class. You can actually work on your homework. I want to go through notes for maybe the next 10 minutes or so, maybe not even that. That way you have about 15 minutes where you can actually work. Okay, I think think you're really gonna like today's topic. It's kind of different. Go ahead and hit the lights running there, Ms. Speaker. Thank you. I'm gonna zoom in on this. Okay, so what we're going to be talking about is called deductive reasoning. This is the, I guess if you're in chapter 2, because that's what we're in, this is like really the first section of chapter 2, if you want to call it by the numbers 2.1. It's one we spend, probably the most time on in chapter 2 is probably this section. Everything else goes really, really fast. Because I think chapter 2 is kind of short, it's like 4 sections, so it's pretty quick. So, but this stuff, I think, is probably the most entertaining stuff we have in chapter 2. It's like we can play games with this stuff. And we'll kind of look at some other things. Okay. What I want to talk about today is just a brief introduction of what this chapter is going to bring, give you some topics that are involved. Okay? All right. Let's see. Problem here. There we go. Okay, so section 2.1, we're going to talk about deductive reasoning. I'm going to do the definition of that here in a second. We'll talk about inductive reasoning. It's the 2 types of reasoning that your brain actually has. Believe it or not, everyone has these 2 types. That's how you function and get from class to class, and that's how you're actually in this room, and that's how you're surviving in your life. Okay? Some people will show more instinct towards one end of the spectrum versus the other, but I promise you, everyone has both. You have to have both. Just be able to survive. There are some people in this world that don't have one versus the other, and they're called savants, and we'll get to that word here in a minute. They're extremely gifted people because they lack something in the brain that it takes away one of these 2. Okay, so we're getting into a little more psychology than math, but I will bring it back to math. You'll see why. Okay. All right. So deductive reasoning. Let's do the definition of this word. This is the intro day where I want to talk about these 2 words. Deductive reasoning is using facts, rules, definitions, theorems, postulates, formulas to make a valid conclusion. These are all the different things. Now, some of these things you've never seen the words before. Like the word theorem is something we're going to get into this chapter for the first time, because now we start getting into a lot of properties, not just a bunch of vocabulary terms. Theorems are properties in math we do not assume are true. We have to prove them to show why they work. They actually take conscious thought to prove that yes, this works for this picture every single time. Postulates, on the other hand, is an assumed truth. Postulates are assumed truths, stuff we take for granted. They're actually called axioms in math. Something that is so blatantly obvious that it's almost difficult to prove it because you can't prove it. It's like, prove why 1 + 1 = 2. I don't know, how do you prove that? Other than showing fingers and, 1 + 1 is 2 fingers, right? It's almost impossible to prove. There's certain things we just take for granted. Basic computational stuff. Add, subtract, multiply, and divide. Stuff you're supposed to learn in elementary days, those are postulates. We just assume they're true. Now when you start mixing them together, that's what makes properties and theorems and stuff. Formulae, plural, right? Definitions, you've already had a lot of those. Rules, we're going to get to, facts. You put all this stuff together. Basically what I'm telling you is deductive reasoning is purely memorization. You probably have memorization. You know how to write your name. You know how to tie your shoes. You know how to get from class to class to class. You memorized your schedule. That's deductive reasoning. Some people are really gifted at deductive reasoning. Extremely gifted. History class. If you go to history, a lot of people will say, oh, history is my favorite class. Yeah, history is awesome. I took history in college. I almost became a history teacher. I have almost a minor in it. Because it's a lot of deductive memorization. It's not a lot of practical use. It's just memorizing. Some people are gravitate towards that. They like it. I like history just because of the facts and stuff that are involved. But there's gifted people. One of the most gifted people in the world is a savant. I'll get to that word here in a minute. Named Kim Peek. Kim Peek unfortunately passed away in 2009. Kim Peek was the world's most gifted savant for deductive reasoning. What I mean by that is Kim Peek, what a savant is somebody who lacks a certain ability in their brain that for him, he had extreme memorization. Like what I mean by extreme, Kim Peek, when he read a book, could memorize the book after he read it. It was completely memorized, word for word, cover to back. And he didn't take time. He could read a page in like a millisecond. He just skimmed through the page, flip the page, skim through, and every word was memorized perfectly, in order. And he could recite the book at any page, any word that you wanted him to. You could say the word, he would just start reading it out loud to you, right then and there. He had every book. He had like 35,000 books in his collection, all memorized word for word. Extreme memorization. But the problem was, if most people were to talk to Kim, I'll show you a video of Kim here in a minute, he suffers from mental disability. Because of his extreme gift in deductive reasoning, he lacked inductive skills, and his inductive skills are how he socializes and how he interacts. Kim Peek was so gifted at memorization, but the problem is he couldn't even dress himself in the morning because he was physically challenged. He just couldn't. You could ask him, what was the sports score in 1947, who played, what was the weather, what was the date, what was the day of that day, and he would immediately say it's a Monday, it was cloudy, it was 67 degrees, and the score of the Yankees game was 25-30, and he would read off all the stats to you, because that's what he read in the newspaper that day. But he couldn't even dress himself in the morning, he couldn't even feed himself. But he was extremely gifted. He was actually considered he was considered to be a human Google, because he could recall facts so fast. He could recall facts faster than Google could, like milliseconds, right? I'm going to show you a small video of Kim, right? Again, he passed away. They actually made a movie based on Kim's life. The movie was called Rain Man back in the 80s. It was with Tom Cruise, and it was a well-known movie, but it was based on Kim Peek's life because of his extreme gift in memorization. Let me get rid of this. Okay, here's a small clip of Kim. Oh boy. It's gonna be loud.
Saturday and this shit's Friday.
Yeah.
When's your next Thanksgiving?
I love him.
I have so many things in me that you can't even guess them all. You know that?
Kim Peek has one of the weirdest brains in the world.
He's become a living Google.
What Kim represents is the dark side of the moon. He is in love with knowledge for the sake of it.
One day.
He's a confounding mixture of disability and brilliance that neuroscientists are determined to understand.
It's a very exciting opportunity for us to find out what makes the human brain unique. He just amazes me. The life.
Okay, so what you're actually seeing, what he was doing on one of those screens where they had like him strapped to a computer with like a camera in his eye, is that Kim had this rare ability other than memorization. He could look at a picture and in 1 second tell you exactly how many items were on the picture. Like, so one of the things in the movie Rain Man was one of the waitresses dropped a box of toothpicks, and he looked down and he told her that there was like 364 toothpicks on the floor. Like instantly, he just knew it. He could count instantly in his head. And it was one of his rare abilities, and they tested him, he could do it. He could look at a picture, and what they did is they put like letters on the screen, and they could ask him, hey, how many X's are on the screen? No, there's 1,242 X's. Like instantly knew how many there were without having to put any mental thought into it. It was just a rare ability. As you can tell, he's very challenged, physically, mentally, but his abilities were off the chart. He would be on Dave Letterman, that was a talk show back in the early 90s and the early 2000s. It's kind of like Jimmy Fallon now, where Kim would go on there and Dave would just ask him a bunch of questions of books he's read. But you could ask him questions, he could recite answers to you, but he can't just have a normal conversation. He waits for questions and then he answers it. Like one of the questions he said earlier is like, a lot of people ask him what their birth date was, and he could tell them it was a Monday and what happened on that day. who's very, very gifted. Because at anything he reads, he knows instantly, and he can recall it instantly. There's no off switch. And so it's kind of a rare ability. It's called Savant, right? It's extremely gifted. Now, going to the other side. So the other side of the moon is called Inductive Reasoning. So this is the complete opposite side. This is my last slide of the day. Inductive Reasoning is where you have, you can basically reason through like a very tough problem using patterns, observations, common sense. These are the big things that help you with inductive reasoning. The most extreme savant in the world, savant is somebody that has an extreme ability, that's a savant, is a young man, Daniel Tammet. He's about my age. Daniel Tammet was a young man that lives in Great Britain. He currently teaches at Oxford College in Great Britain. Like, that's the most prestigious college in the world, and he teaches theoretical mathematics. They actually say that Daniel is almost smarter than theoretical physicist Stephen Hawking. Like, Daniel is the most extreme case of savantism, like now, today. Daniel has that ability. He can do extreme memorization like Kim Peek. But what Daniel has is, for some reason, he doesn't lack that social or that just ability to have a normal conversation. Daniel can actually talk you through his process, what he's thinking about. He can hold a normal conversation. He lives a normal life. He doesn't have a caretaker like Kim did. Kim had his father that would take care of him physically his whole life. But Daniel is just a normal professor at a college. But Daniel set the world on the map when he went to Oxford College when he was, I think he was 21 or 22, and he proved a Guinness Book of World Records where he recited pi, this is pi, right, to 22,000 places. Okay, 22,000 places of pi. This is like 26 numbers up here on the board. He did 22,000. It took him like 6 hours to do it in front of an audience. But he did it. They had pages, and they would go through, and he would take breaks every now and then because he would just recite number after number after number. He could do calculations in his head extremely fast, where he can multiply really big numbers or take square roots of numbers, really big numbers, and decimals, and he could do it instantly. And you can kind of see his process, what he thinks about. And the reason why he has this weird ability is he said he had an accident as a child when he was about 3 or 4 on a playground where he hit his head really hard, and he could just instantly see numbers in his head. Where when somebody asked him a question, it would just be like a firecracker going off in his head, where it was just like a little pop going on his head, and he would just see the answer instantly. And it would go through all the numbers. And so when somebody says pi, he just sees numbers. It's like going off like he's almost having it's almost like a seizure, but he can just recall what he's seeing out loud, and it doesn't look like it's affecting him. Daniel is one of those rare people, and they thought it was just a memorization trick. Like he's learned something that can teach him that. But Daniel can also learn languages really fast. So he said he had extreme memorization work, and to prove that he has inductive skills, not just deductive, and that he's not just fooling people, he proved that his inductive, like common sense and patterns, he learned a new language in less than 7 days, the entire language. He learned, and they challenged him. The Discovery Channel is doing all these videos that I'm showing you right now. They said to prove that he's a savant and prove that he has inductive as well as deductive, they wanted him to learn a language that they would pick in the world. And they would show up on his doorstep a random day, present him, and he would be on the news 7 days later and have to give an interview in that language only. And he did it. They gave him one book. He went home, he read the book, and he could speak the language after about 3 days it took him. And he knew almost everything. In fact, after he went on, the language they presented him was the Icelandic language, which is one of the hardest languages in the world to learn. And after his interview, the interviewer said he spoke better language than he did, and he's been living in Iceland his whole life. And he learned it in 3 days, like the entire language, like everything. Extremely gifted. But that shows the inductive. He used patterns and observations, and he recognized that there was ties between Latin and Spanish to the Icelandic language, and that helped him learn it faster. He could like do patterns, he could see connections. I think as of like 2012, he had like 9 different languages that he knew. I think he's going up. He's trying to learn almost every single one he says. That's impressive. Not a lot of people can do that, but he's extremely young. And so you'll get to see him, he's British, he's got terrible teeth, just get over it. But here he is, he's quite young, I think he's my age, in fact. Let's see, here we go. Nope. All right. So here's Daniel Tammet. And again, these are all Discovery Channels because Discovery Channel does 1 week a year where they feature savants.
I'm seeing things in my head like little sparks firing up. And it's not until the very last moment that those sparks tell me what on earth they mean.
I've never encountered anyone like this. He absolutely blew my mind.
To scientists, this man is a gold mine, a once-in-a-lifetime opportunity.
This could be the linchpin that spawns off a new field of research.
Why are they all so excited?
Genius. It's not human.
Daniel Tammet claims that since he was 4 years old, he's been able to do huge calculations in his head. So in August 2002, we dropped by, armed with a calculator.
And you can't see this.
No, they did like, I think with Daniel, they did 3 different interviews, because Daniel's kind of a rarity where Daniel can actually explain what he's experiencing. Like with other savants, they can't, they can just basically just tell you knowledge, like the things they've read. But Daniel can actually go through things, and they didn't know, Daniel didn't know he was being secretly recorded. They had like a pinhole camera in this guy's shirt that's pointing right at the calculator that's in front of him to see if Daniel was actually faking it. And this is the first interview that they had with him. And he can do extreme calculations where, I'm not going to play the whole video because I want to give you time to work, but he did calculations where it went past the calculator. They had to go to a computer, a Windows computer, to actually bring up a computer that could go more decimal places when he was dividing in his head. It's extremely gift. And I mean, a lot of people cannot do this. And so, but he teaches at Oxford now because his knowledge is like incredible. I mean, he can learn things so fast. He can teach you in different ways and how he sees it. He's incredible. He's super young too. I mean, I think he's 2 years older than me, but yeah, he's definitely beyond anything anyone's ever seen before. But I definitely recommend these. These are Discovery Channel stuff. You know how they have Shark Week. They have a week where they feature superhumans. They call it Superhuman Week. And savants are usually who they feature that week. And it's about an hour special. But yeah, they're pretty cool. So, but today I'm going to give you the rest of the time today to kind of work. Make sure you're taking your time on that. Homework's due tomorrow. Keep that in mind. You're set up at 61 on page 70. Ms. Spear, if you can hit the lights for me, please.